Okay, so first, talking about just really kind of the definition. The best example I can give you of absolute value is the distance, okay, which is that's what we use here as in the definition as well. It is the distance a number is from 0 on a number line. Okay, again, the best example I can give you is maybe you're measuring something. Okay, you can never have a negative measurement. If something is 6 feet that way, that doesn't mean that it is negative 6 feet. Okay, going that way on this side of me would be negative 6 feet. So you'll see that used a lot in examples. The absolute value symbol is that right there. It just looks like two lines. I will do my best to make sure that that does not look like one X and then a line after it. To put that in your calculator, please make sure you know this shortcut. And there on the number line, again, the absolute value of -2 is 2 because it is 2 units from 0. The absolute value of +2 is 2 units from 0, so it would be 2. So hopefully some easy questions here. Hunter, the absolute value of 6 would be 6. What two numbers, when taking the absolute value of, would give me 9? Say that again, Abby.
-9 and 9.
-9 and +9. Going over to 3. Why is this false? Because it cannot be negative right there. Make sure that whenever you have multiple terms inside the absolute value bars, you will combine like terms. Okay, and you'll do that inside before you take the absolute value of it. So -2 plus 5 would be 3. Is the absolute value of 3 3? True. Let's talk about the parent function. You saw this on the day where we talked about all of the parent functions. Just y equals the absolute value of x. Okay, to do these, we're going to, let's do these x values, -2, and then go up by 1. So just going down these list of x's, the absolute value, if I plug each one of those in for x, that will give me my y. So the absolute value of -2 is what? -1, 0, 1, 2, 3. So we'll come over here and graph these. So which one of these points would be the vertex? 0, 0. Someone explain what I mean when I say vertex on that graph. Do what? Okay, so kind of where both those lines meet, it's where, in an easy way to say it, it's just the point of the V. Whenever you're filling in the table, I highly recommend that you identify the vertex some way. if you look at, if anytime you come in here and I have my key to something, that is usually how I will identify the vertex. Okay. So next, let's go down. Let's talk about those transformations again before we go on to graphing a little more complicated, a little more complex equations. So we've talked about the C value already a little bit. If it is plus C, which direction is that going to go? Left. Okay. Remember, anything inside the absolute value bars, so the B and the C, those are going to affect the X values, and it's always going to be opposite of the way you think. So if it's plus C, it's going to go to the left. Which means if it's minus C, it's going to go to the right. And then outside, it's going to affect the Y values, and it's going to do about what you think it would do. So if it is plus D, which direction is that going to go? Up. Minus D. Down. Also, write this in on the transformations. This is my mistake. There should be parentheses right there. So the A value, since it is outside the absolute value bars, and normally we will see parentheses there, but this one, it'll be the absolute value bars. Since it is outside, is it going to affect the X or the Y? The Y value. And if A is greater than 1, and again, since it's the Y, it's going to be some kind of vertical transformation. Is it going to vertically stretch it or vertically compress it? Vertically stretch. And then so if A is less than 1, it is going to vertically compress. If A was negative, how would that affect it? Does anybody remember that? It's outside, so it's still going to affect the Y values. But if I had negative absolute value of X, that would just take all these and make them negative. And so what would that do to the graph? Reflect over what axis? The X-axis. The B value, again, we won't see a lot of the B value, but it's inside, so it's going to affect the X. It's going to be horizontal. And this one is going to, if B is greater than 1, it is going to horizontally compress. And B is less than 1, it is going to horizontally stretch. Probably one of the most common ways we will see it, though, when we do. If b is negative, what's that going to do? Reflect over the y-axis. Off to the side here, to the right. And again, this is one of the things I want you to make sure that you can identify before you walk out of here today. To find the vertex, that's all it is. I put negative in front of C because it's going to be opposite the sign in the equation. If it's negative 2, in the equation, if it's x minus 2, the x value of your vertex is positive 2. If it's x plus 3, the x value is going to be negative 3. So, let's come down here. So if I was to look at that equation right there, Mr. Ogden, please pick your head up. Thank you. That x minus 4, Natalie, which direction is that going to move the graph?
It's going to go right.
It's going to go to the right 4 units. And that plus 5 is going to go which direction?
Oh, that's going to go up.
Up. So there's my vertex right there. Okay. I'm going to take that. We'll go ahead and graph it. And then in the table, I need to go ahead and write the points, the x values that would be around that. After that, let's talk about the a value up here, which, like I said, most of the time we'll talk about it vertically stretching, compressing, reflecting, which is true. But I told you that on this one, along with linear, it's almost like it has a slope. Okay? So that a value is negative 1. I want you to see that as your slope. Okay? Now, if I know that it reflects, so normally it would look something like that. If it reflects, my slope is going to be negative 1. So I'm going to go down 1, right 1. Okay. But it is also going to have the opposite, whatever that number it is, the opposite of it is going to be the slope of the other side. So I will go down 1, left 1. And then I can put those y values in that I found. So I had 4, 5. Here I have 5, 4, and 3, 4. And then I had 6, 3, and 2, 3. Let's say I just gave you the table. How could you identify that 4, 5 is the vertex? Someone look at that, see if there's anything that kind of sticks out about it. Okay. It's the point where it looks like it builds up to it and then it starts to go back down.
The 5 on Y is the highest number it goes to.
Okay. It's the highest number, but sometimes that vertex could also be the what? The lowest number. Okay, if it didn't reflect over the x-axis, it would go down to a point and go back up. So it could be the lowest number. What else about that table? What might be a good rule that we could go with defining the vertex from a table?
It's the only y value that is not repeated.
Okay. You're getting kind of close to what I'm searching for here. What I want you to look for is the y value that has the same number above it and below it, which is kind of what Jesse was getting at back there. Okay, so you find the y value that has the same number above it and below it, and there would be your vertex. Going to number 2. Jillian, looking at that equation, what would my vertex be?
Negative 5 and 3.
-5, 3. I'm going to put those values in there. I'll go ahead and graph my vertex. What would my slope on this one? What are my 2 slopes on this one? Manny, what's the a value in that equation?
2.
Okay, so there's one of my slopes. What's the other one going to be? What's the opposite of 2?
-2.
-2. So I'm going to go up 2, right 1. And then from the vertex, I will also go up 2, left 1.
So the 2 is always like your slope, pretty much?
That a value? Yes. What is in the equation will always give you the slope of the part that's on the right side of the vertex. So that had a slope of 2 on that first example. That had the slope of -1. The left side is going to be the opposite of that number. Now I forgot to write it on here, but make sure that you identify the vertex from the table. What would the domain of both of these graphs be? Somebody tell me. Neve? Negative infinity to positive infinity. Domain of absolute value is always that. Now let's talk about the range. On the first one, and do we do range bottom to top or top to bottom? Nathan, bottom to top or top to bottom? Bottom to top. Okay, so on this first one, how far down is this one going to go? Negative infinity. What is the highest point of that graph, Zach?
Which graph?
The first one. What is the highest y value?
5.
Is it equal to 5? Yes. Josh, what would the range on the second one be? 3 to infinity.